Design and analysis are two separate functions which are often confused to the point of being synonyms within our profession. It is important to distinguish because you need to approach them in the proper order. One must design first before one can analyze. In open channel engineering, the simplest aspects of design can be summarized into three choices the engineer must make: shape, slope, and material. When we talk about installing a new flood diversion channel or other sewer facility, we must first decide the shape of the channel, or more precisely, the shape of the channel in section view. The three most obvious choices before you are the rectangular, trapezoidal, and triangular or V-ditch shapes. Imagine water flowing out of the page towards you. I am positive that you've seen a channel that resembles one of these shapes. Other less obvious shapes include a curb and gutter, as well as a circular channel. Generally speaking, we only use curb and gutter shapes at the side of a roadway, and circular channels, also known as pipes, underground. But the reality is that the shape of the channel is a choice that the engineer must make. When it comes to slope, it may not seem obvious at first that this is an engineer's choice. We have our given topographic data, so the wise engineer will simply slope their channel at whatever the natural slope is. The slope simply becomes the rise over run, or change in elevation divided by the channel length. In the case of topo, where the slope of grade changes, then the engineer must decide how the transition will happen to minimize the excavation cut and manage the channel velocity. So even though the slope of the channel is typically based upon the existing grade, if the flow velocity is too high, then it can be adjusted slightly to help slow the velocity to keep it within the stated criteria. The final choice is the channel material. The most basic channel material out there is earth, just dirt. The most resilient material available is concrete. However, in between these options exist other materials with different levels of erosion protection. These include grasses, riprap, which are just rocks, and gabions, which are rocks in a wire basket. It is tough to beat reinforced concrete for strength and durability, but concrete-lined channels have a negative impact on river ecology as well as stormwater runoff quality. We now know that rivers pre-treat our waters as well as provide habitat for an unimaginable number of plants and animal life. A movement within the past couple decades has focused on restoring rivers and wetlands from concrete to more natural and native materials. Therefore, a channel material can be landscaped with boulders, grasses, shrubs, and other vegetation to filter the stormwater, which can provide, over time, habitat. As you can imagine, an earth-lined channel will have a much lower max velocity than concrete. Therefore, it is important to point out that the velocity criterion that is used to determine if your design is quote-unquote good enough is directly related to the material you choose. For example, even though the soil properties can vary, it is often stated that an earth-lined channel has a max velocity of 5 feet per second. A grass-lined channel has a max velocity of 8 feet per second. And again, this can vary by the type of grass considered. Finally, a concrete channel has a max velocity of 30 feet per second, just to give you an idea about the range in values.